Okay, so in this video we're going to talk about factoring quadratics with leading coefficient of 1. There's some basic properties I want to talk about before we get started. And one of the basic properties I want to start with is the identity property of multiplying by 1. And what's important is that if you take a number and you multiply it by 1, you get itself. And that's going to be an important concept in the technique that I'm going to share with you, because the technique that we're going to go over today on this video, okay, only deals with leading coefficients of 1. So the shortcut to this, it's not so much as a shortcut, it's understanding that when multiplying by 1 doesn't do anything. It's also understanding that 1, okay, not really necessarily called a prime number, but acts like a prime number where its only factors are itself. So with this video, okay, the next thing we need to talk about is how are quadratics made. And quadratics are made when you take a linear, okay, and you multiply it by another linear expression. So if you take two linear expressions, all right, you will create a quadratic. Now, that's also important to know is because we've, in previous videos, I've talked about how to multiply a binomial times another binomial. And when you have quadratics, okay, they're created through the multiplication of two linears. So the first process to understanding how to factor is knowing where it comes from. And the second part of the process is going to be knowing that when you multiply things together, what they create. So let's go ahead and get into factoring so that this makes a little bit more sense as opposed to a general discussion. But let's take a look at our first example. So here we have a quadratic, and our quadratic is x squared plus 7x plus 12. And in this example, okay, it has a leading coefficient of 1. And what it means to have a leading coefficient of 1, it means that the number in front of the x squared is a 1. Now, the reason that that's important is because when you go to factor this, okay, it's important to know that there's only one way to make x squared. And to make x squared, it's x times x. So remember what I talked about just previously, that quadratics come from linears. So to set these problems up, what you need to know is that you're going to set up a linear equation for each factor. So the linear expression that you're going to use for each factor, it has to start with an x. That's what makes something a linear expression. So from here, what we need to know is what is the process of multiplying a binomial times a binomial. So when you did the distributive property, when you multiply two binomials, okay, what you need to know, all right, is that you took this first x and you distributed it to the first term and you distributed it to the second term, okay? And then whatever number was here, you distributed to x and then you distributed to this last term. So what's important to know is that you have, first off, a quadratic, so you've got that first part of factoring taken care of. So essentially, you're splitting your x squared into two linears, all right? That's step one to this. Step two is recognizing, okay, actually skipping the middle term, all right? For a second, we're going to skip this for a second, and we're going to go to this 12. Now, 12 is called a constant. And the only way that a constant can be made is by making a constant and multiplying it by another constant. So that means to make the number 12, that this number here and this number here, the second numbers in your linear expressions, must both be constants. So now let's just take a look at this really quickly and ask ourselves, what two numbers multiply together to make 12? So if I take two numbers and I multiply together to make 12, I have the possibility of doing 1 times 12. I have the possibility of doing 2 times 6, all right? And I have the possibility of doing 3 times 4. So now what's important about this is you just can't choose any one of these pairs at random, all right? What you have to make sure of is that when you multiply the two numbers together, so whatever pair you choose, you're going to have to make sure that they do multiply together to make 12. But then after that, you can't forget that this x over here is also going to multiply it, and this x over here is going to multiply the other one. And what those two x's, when they multiply the two empty spots that I'm talking about that I'm going to fill in here, that is when you have to consider which group makes 7x. So a common phrase which you will hear your teacher say is what multiplies together to make 12, yet adds to make the middle term. So in this group right here, 1 and 12 makes 12, but when added together, it makes 13. So 13 is not 7. If you take a look at 2 and 6, when you multiply 2 and 6 together, they make positive 12, but when added, they make 8. So then I take a look at the last group, and it's 3 and 4. So 3 and 4, when multiplied together, make 12, yet when added, guess what? 3 and 4 also make 7. So if I take a positive 3 and a positive 4 and place them in there for my new linear expressions, what you will have is you are going to have what two things multiply together, okay, to create this product. So what we're doing in this problem is we're looking at our quadratic as a product, and we're trying to figure out what are the two things that multiply together to make it. Now, what's nice about this is that all quadratics are unique, meaning there's only going to be one particular set of pairs that actually multiply together to make it. So let's just go through another example and go through that process again. So again, in this video, all right, what we're dealing with is a leading coefficient of 1, which is nice because there's only one way to make x squared, which means you take x and you multiply it by x. Now, you also need to remember that quadratics are made by taking a linear, okay, multiplied by another linear. So that's why I'm separating those two x squareds apart into new linear groups, because this is going to be a linear expression and this is going to be a linear expression. All right, so when I have that, and linear expressions, by the way, are in the form, right, you've seen them before, just in case, it's this mx plus b. It's just for us, our m is always going to be a 1, which is kind of nice. So what we're kind of dealing with is just this x plus b, where we're trying to figure out two values to place in for our b's, okay, that multiply together to make our last number, yet combine to make that -5 in the middle. So the thing I have to look for is what are some things together that multiply to make a -6. So -6 can be made by multiplying +1 times -6. It can be multiplied by taking -1 times it by +6. You could take +2, multiply it by -3. You could take -2 and multiply it by +3. So there are all of my options for me to be able to multiply together to make -6. So what I'm just simply going to do is I'm going to go through each one of these now after I figure out all of my multiples that make -6. And then I'm going to figure out which one of these can combine when added together to now make my -5. So I take 1 plus -6. 1 plus -6 indeed is -5. And there we go. So when I write them into my groups, it doesn't matter the order I write them, but I will write one group has +1 and the other group will have a -6. And there you go. It is now factored. So my final answer to this one would be x plus 1 times x minus 6. And now my quadratic has been factored. On to the next example. So the next example, it says x squared minus 9x minus 22. Again, what's nice is we're dealing with x squared. And there's only one way on the earth to make x squared. Okay, so and the way that makes it is x, and the other x goes into the other linear group, because when you're doing binomials times binomials, the way you're going to multiply your x's is through distribution. So going on and continuing with this problem, the next thing I have to do is fill in my constants. And when I fill in my constants, I just have to keep in mind that they're going to have to combine to make this -9. So what are all the ways or all the things you can multiply together to make -22? And if you can do this very quickly without having to list them out, and you know the answer, great. You can just write the answer in there. For me, for the purpose of this video, I'm just going to write them out. So you have 1 times -22. It could have been the -1 times +22. It could have been 2 times -11, or it could have been -2 times +11. And that's it. I don't have any other factors for 22. So now I'm just going to look for which group, when added together, make negative 9. 1 and negative 22 make negative 21. Negative 1 and 22 make 21. 2 and negative 11 make negative 9. So there you go. That's the one that matches up. So when I go to write this into my group, I'm just going to I'll write it as negative 11 and then positive 2. And there you go. You now have it factored. Now, just because we're down this far, if you want to, you can always check your work by simply doing the binomial distribution. So multiplying a binomial times a binomial, you take x times x, you will distribute that x to the 2, okay, which is where this idea of 1 times 2 comes into play, that idea of multiplying by 1, because I will get x squared, okay, x times x is x squared, plus 2x, and then I get negative 11 times that x, which is negative 11x, and then I get negative 11 times that positive 2, which gets me the negative 22. So here is the reason why the teachers say to you what multiplies together to make the negative 22, because all linears in the video that I'm doing, all right, so specifically these trinomials, are going to have things that are constants. So these two numbers in your linear expressions are constants. Those are like you can think of as your b's for mx plus b, all right? And then your first term has to be linear, so it's just going to be an x. So when you do the distribution, look what happens. You end up creating like terms. And the like terms that you create, all right, you add them together, which is why your teacher will say to you, or why you'll commonly hear is, what multiplies together to make the constant, yet adds to make the middle term. So for this particular problem, we found two things that multiply and make negative 22, and then of their pairing, we found out which ones indeed actually made negative 9x. And that's your final answer. So it's x minus 11 times x plus 2 would be my final answer that I would box up on a quiz. All right, let's take a look at one more example. Okay, the next example says x squared plus 8x plus 24. So again, what's nice is remembering that quadratics are made by taking a linear factor, multiplying it by another linear factor, and our factors are going to be linear expressions. So we're basically, because this is a 1, we don't really have an m, okay? We just have x plus b, and our b's are going to be factors of 24. So we take a look at 24. So give me two numbers that multiply together to make 24, that when added make 8. So I could have 1 times 24, I could have 2 times 12, I could have 3 times 8, I could have 4 times 6, and then that's it. That's all of them. So then what I'm going to go ahead and look at, I'm going to look at each one of these, and when I combine them together, I'm going to ask myself, do any of these combine to make positive 8? So 1 and 24 make 25, 2 and 12 make 14, 3 and 8 make 11, 4 and 6 make 10. So none of these equal 8. So that's weird. So because none of these equal 8, all right, this quadratic, okay, is what we call to be prime. And the reason we call it to be prime is because it can't be broken down into two things that multiply together. What does it mean to be a prime thing, right? Prime. So think about 13. All right, 13 is what we call a prime number, because the only thing you can do is take 1 times it by 13 to make 13. Well, this quadratic, ironically, does not have two linear expressions that you could use to multiply together. So this quadratic, okay, is what we say to be non-factorable, which means we write that the answer is prime. So we don't rewrite that answer, we just say it's prime. It's a little bit easier. Now, if your teacher wants you to write the answer, that's fine. But just so you know, the only way that this quadratic is made is by uniquely having it. So I hope that helps with whatever you're doing, but please do know that not all quadratics are indeed factorable. The ones before were because one of their pairs worked out to make that middle term. But that's how you go ahead, and that's how you factor quadratics.